Alright guys, today we're starting on Module 1, Lesson 2, and this is going to be a little bit of a longer lesson, but we also get into something a little interesting. We're going to look at doing certain operations with our exponential notations. Today specifically, we're going to go over how to divide and multiply exponential notations if they have the same base. Now remember, a base, well, it's supposed to be right, let me see. Alright, there we go. Remember that a base is the bigger number on an exponential notation, and the exponent is that smaller number at the top that tells you how many times the base was multiplied. So in this case, 3 is our base and 2 is our exponent. So let's look at the case of, let's go with 3 to the 4th power times 3 to the 2nd power. Pause this video and think to yourself, how can I represent this in a more simpler form? Well, if you thought about it, I can see that 3 to the 4th power, we know what that means. That just means it's repeated addition. So I have 3 times 3 times 3 times 3, total of 4 times, so I'm done with that. And that is also being multiplied by 3 to the 2nd power. So that means I'm multiplying by 3 to the 2nd power, which would be 3 times 3. So all you see here is that I did repeated multiplication times repeated multiplication again, and got a just longer repeated multiplication. So if I would simplify this, I have 3 times itself, 1, 2, 3, 4, 5, 6 times. So that's the same thing as saying 3 to the 6th power. So what do you think I can derive from that? What rule do you think I can come up with? Well, if you have the same base on an exponential notation, let's say I have 4 to the 3rd power times 4 to the 5th power. They both have the same base. If they do have the same base, then that means you can simply say, and if they're being multiplied. If they have the same base and they're being multiplied, that's the same thing as saying I have 4 to the 3rd power, and then the exponent of 5 is also being added. That means I have 4 to the 8th power, because I'm already doing 4 by itself 3 times, and then 4 times itself 5 times. So if I just add those two together, I'll get 4 by itself, 4 multiplied by itself 8 times. It would be 4 times 4 times 4 is the 3rd power, times 4 times 4 times 4 times 4 times 4 5 times, which means it would be 1, 2, 3, 4, 5, 6, 7, 8 times it's being multiplied. So I would have 4 to the 8th power. So knowing that, let's begin our exercises. We're going to start with exercise 1. I have 14 to the 23rd power times 14 to the 8th power. Well, my first question is, do they have the same base? And the answer is yes, they both have 14 as a base. Now their exponents are 23 and 8. And I know that if I'm multiplying two things in exponential notation, then I could just take the base and do 23 was one exponent, plus that 8 is another exponent, and you will have 14 to the 31st power. And that's your answer whenever you are multiplying by exponential notations. Exercise 2, negative 72 to the 10th power times negative 72 to the 13th power. Do they have the same base? They do. They both have negative 72. Now remember, whenever you're writing exponents, you want to make sure all your negative numbers are in parentheses so that we make sure we take that negative number first, not the exponent first. We need to show that we have a negative number. And then I have negative 72 to the 10th power plus the 13th power, because they both have the same base and they're being multiplied. And now I know that I have negative 72 to the 10th plus the 13th power, because remember, it's just repeated multiplication across the board. So I can just add those exponents together and get negative 72 to the 23rd power. Exercise 3, 5 to the 94th power plus times 5 to the 78th power. I'm getting old, guys. So they are the same base of 5, so it would be 5 as the base to the 94th plus the 78th power, which will give you 5 to the 172nd. If y'all don't want to do this addition right now, you don't have to. What I want to see whenever you're doing these exercises is that you know that whenever you take exercise 4, for example, the base is -3. Remember those parentheses. I want to see that you know that whenever you are multiplying exponents of the same base, that you know that it is 9 plus 5 as the exponent. I want to see that all across the board as your answers. I don't even care if you add it after. I just want to see that you know that this over here means the same thing as this. So I do definitely want to see that you know that the exponent is 9 plus 5. Now exercise 5, let A be a number. Like I said, this is a variable. A variable is still a number. We just don't know what specific number that is. So I have A as my base. And let me just pull this up on my computer so I can see the numbers better. There we go. So it is A to the 23rd power times A to the 8th power. So that would just be 8 as my base to the 23rd plus 8. That's going to give me my answer. Let F be a number. F is my base because they are the same base. 10 is my exponent plus, is that a 13? Sorry, guys. Let me see if I can zoom it in. 10 to the 13. That's a little better. Yep. Exercise 7, let B be a number. B is my base. They are the same base, so it will be 94 times 78. And then exercise 8, let X be a positive integer. If -3 to the 9th power times -3 to the X equals -3 to the 14th power, what is X? So we kind of have a first taste of algebra already in this lesson. We see that we have -3 to the 9th power times -3 to the X power, the power of X, equals -3 to the 14th power. All right, ignoring this over here. I can't cover it. I went to grab my hand and cover it. Ignoring this, what do you think we can do to prove that all of this equals 14? What would X be? A lot of you are going to look at it and say, well, Mr. Stefan, I know that 9 plus 5 is going to give me 14, so X has to be 5. Sure, absolutely. We would set that up because we know that -3 is the base because they share the same base, and the exponents would have to be 9 plus X equal -3 to the 14th power. And then yes, you ask yourself, if I have to add these two and it gives me 14, then I can make a little equation over here. I know that 9 plus X equals 14. If I wanted to find out what X was, I'd need to get it by itself. You remember this from 7th grade? Subtract 9 from both sides. I'm left with X on one side equals 14 minus 9, because remember, if I subtract 9 from this side, then I have to do it from this side. So 14 minus 9 gives us a 5, and you're left with X had to be 5, because if X was 5, then it'd be 9 plus 5 gives me the exponent of 14. Then we move on to exercise 9 and exercise 10. It asks you what would happen if there were more terms with the same base. Write an equivalent expression for each problem. Well, let's look at it. Let's not even look at exercise 9 yet. If I told you I had 2 to the 2nd power times, 2 to the 2nd power times 2 to the 2nd power, are all the bases the same? Absolutely. Now remember, it's multiplication. It is all the same thing. Once again, we have repeated addition over and over and over. 2 to the 2nd power is 2 times 2, times 2 to the 2nd power is 2 times 2, times 2 to the 2nd power is 2 times 2. I add all that up together and I get 2 to the 6th power. It is exactly the same thing. But you have to remember those bases have to be the same number in order for you to add their exponents. So if I had 9 to the 4th power times 9 to the 6th power times 9 to the 13th power, then I would get 9 is my same base times to the 4th plus the 6th plus the 13th power. And that would be my simpler version. And now I have exercise 10, 2 to the 3rd power times 2 to the 5th power times 2 to the 7th power times 2 to the 9th power. My base is 2. Exponent would be 3 plus 5 plus 7 plus 9. And you can simplify that if you want. But once again, I just want you to see that all you have to do is add the exponents if it's being multiplied by the same base. Can the following expressions be written in a simpler form? If so, do it. If not, explain why. All right. Right here I have 6 to the 5th power times 4 to the 9th times 4 to the 3rd times 16 to the 14th power. Can this be simplified? It can, but not entirely. Because remember, you can only add exponents of the same base. So let's look at what bases I have that are similar. I have a 4 right here and a 4 right here. So that means I can do 4 as my base, exponent of 9 plus 3, and then I still have to multiply it by the rest of it, which I have a similar base of 6 as well, with an exponent of 5 plus 14. I couldn't simplify it all the way, but you can still simplify the different bases. So now let's look at 2 to the 4th power times 8 to the 2nd power. And what they did here was they took 2 to the 4th power, and what they did, they took this 8 to the 2nd power. So let's look at what 8 to the 2nd power is. I know that 8 to the 2nd power is the same thing as 8 times 8, which is 64. They said that 2 to the 4th power times 8 to the 2nd power is the same thing as saying 2 to the 4th power times 2 to the 6th power. So being that 2 to the 4th power didn't change, they're saying that 2 to the 6th power is the same thing as 8 times 8. Let's see if that's true. I have 2 to the 6, which is 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Bring down that other 2, times 2 is 16. Times 2 will get me 36. Oh, sorry. And then times that last 2 gives me 64. So they're right. They said instead of 8 to the 2nd power, we can simplify 8 to the 2nd power to be 2 to the 6th power. And it will be the same thing. All they did was simplify this further. And then now we can add those two base exponents together. I have 2 is my base and 4 plus 6. All right. I want you guys to pause the video and work the next ones, and then I will work them as well. All right, so I have a shared base of -4 and -4 right here, so I know I can add those. I have -4, make sure I have parentheses, to the power of 2 plus 3 times the shared base of 17, 5 plus 7. So that would be your answer for this one. Right here, they do the same thing. They have 3 to the 7th power times 9. Well, if I want to simplify 9, I know that 9 can be broken down in a factor of 3 times 3. So they said instead of 9, they have 3 to the 2nd power. And then you can share, they have the same base, they share the same base, 7 plus 2 as the exponent. Similar base of 15, 15 to the 2nd power plus, let me ask you, what is the exponent of just regular 15? Well, the exponent tells me how many times 15 was multiplied, and if I just have 15, then it was multiplied once. So that would mean 15 over here times another 15 to the 2nd power times another 15 would give me 15 to the 2nd plus 1 times the shared base of 7, 2 plus 4, and then exercise 16. Do I have a shared base? I do not. There are no shared bases. I can't simplify this to where they have a shared base. So there is no way to simplify this because they do not share a base. Exercise 17. Let x be a number. Rewrite the expression in simpler form. Oh, these are interesting. So let's look at it. I have 2 times x. Remember, this is 2x to the third power times, because parentheses mean multiplication if they're right by each other, 17x to the 7th power. Remember, whenever you have something like 2x, this is the same thing as saying I have 2 times ICX. That means there are 2 x's, is 2 times x. So let's look at this and rewrite this to make it easier to see. I have 2 times x to the third power, and then those parentheses mean multiply by 17 times x to the 7th power. Now, do I see something that I can share? Absolutely. These two exponents have the same base. So I can say I have x, or let's do something that you're familiar with. Let's rewrite this in a simpler and more side-by-side form. Let's put the like terms by themselves. So my like terms are x. So I definitely have x to the third power times x to the 7th power. I'm putting those because they're the same base right by each other. And I'm left with 2 times 17. Now remember why I can just move this around? Because of commutative property. If everything is being multiplied, commutative property says I can flip it however I want. Now I can simplify even further. I have x, the shared base, of 3 plus 7 because they're being multiplied, times 2 times 17, which will get me 34. Now, if I want to simplify that even further, remember whenever I have a constant of that number 34 times an exponent, then I can rewrite that as 34 times ICX to the 3 plus 7. And I know if I simplify that even further, I have 34x, 3 plus 7 is going to give me 10. Exercise 18. You guys try that by yourselves. Pause the video. Okay, and now we have let A and B be numbers. We don't know what they are, but we just know that they're A and B. Use distributive law or distributive property to rewrite the expression. So if I have A on the outside of these parentheses, that means A times everything in there. Remember what distributive property is. A times A plus B means I take what's on the outside and multiply it by everything on the inside. So A times A will give me A times A. And then plus A times B is AB. Remember, whenever you multiply variables by themselves, by each other, and you don't know what they are, you just put them together. A times B. When they're right by each other, it means multiplication. Let me simplify this. I have A times A. I know that I can put that in exponential form because it's repeated multiplication, plus A times B. This is not repeated multiplication, so I cannot put that in an exponent. Hey guys, before we move on to the next exercises, we need to learn something about dividing exponents with the same base. So if I have, let's say, 2 to the 7th power over 2 to the 3rd power, if I write this in expanded form, it's the same as saying 2 times 2 times 2 times 2 times 2 times 2 times 2 over 2 to the 3rd power. I can expand that, but I'm not going to yet, and you'll see why. Remember, whenever I have division and it's multiplication across the board and on the bottom, I can cancel some things out. What I mean by cancel is I can take things like if I were to break this up into 2 over 2 times the rest of that stuff and all of this, I can break it all up because it's broken up into multiplication. So I want to make all of this into something that I can cancel out to get rid of this on the bottom so I don't have a fraction or a division problem anymore. Can I make any of these into 2 to the 3rd power? And the answer is yes. I can just take these 3 2's being multiplied by itself and say 2 to the 3rd power times the rest of those 2's, which is 4. So I'm just going to make it 2 to the 4th power over 2 to the 3rd power. And now that I have this is what I meant by you can break all of this up. You can say this is the same thing as 2 to the third power over 2 to the third power, and then times 2 to the fourth power over 1 by itself. So I can cancel these two out and make it 1, so that 1 doesn't really exist because 1 times everything else is just the same thing. It exists, but we don't have to show it. And I'm left with 2 to the fourth power. Or if I wanted to take this original fraction back here, and let's expand that 2 to the third, 2 times 2 times 2, I can just cancel it one by one. I have a 2 up here, so I can cancel a 2. I have a 2, I can cancel a 2. I can have a 2, and I can cancel this 2. I have nothing left on the bottom, so I can't cancel anything else, or divide it and make it 1. And I'm left with 2 times 2 times 2 times 2, which is 2 to the fourth power. And all that basically is saying, guys, is I can do this every time. Or if I have a fraction or a division problem like this, where I have 2 to the seventh power divided by 2 to the third, which is the same thing as having it in a fraction. Remember, 2 to the seventh power over 2 to the third. As long as my exponent is bigger in the top or bigger in the numerator, then I can simply say they have the same base, and I have 7 minus 3. Just like multiplication is to addition, division is to subtraction. So if I'm dividing two things, such as 8 to the fifth power over 8 to the third power, and the base is the same, and the exponent on top is higher, then I could simply say the base is the same, and I'm subtracting the exponents. Because remember, it's the same thing as just canceling those out, and so I have nothing on the bottom anyway. So this would disappear, and I'd be left with 8 to the 5 minus 3, which is 8 to the second power. So that's how division works of exponents. And yes, you will end up encountering some with higher exponents in the denominator, but we're going to get into that in a later lesson. So let's go ahead and get started on our next set of questions. Knowing that, let's go back to our exercises. 7 to the ninth divided by 7 to the sixth. My exponent on top is bigger, and they have a shared base of 7, so I have 7 to the 9 minus 6. 8 fifths to the ninth power divided by 8 fifths to the second power. My exponent on top is bigger, so I can just subtract them. My shared base is 8 to the fifth power. Make sure those parentheses are in there so your exponent doesn't look like it's on the 8. And then I have 9 minus 2. My shared base right here is negative 5. 16 minus 7. And then 13 is my shared base. My exponent is bigger on the top, so 5 minus 4. We will do some, I think it's in lesson 5, where the exponent is not bigger on the top. You can still do it, but for these lessons, we're going to just be doing it, the subtraction, whenever the exponents are bigger on the top. Right here, let a and b be non-zero numbers. What is the following number? Well, it's the same thing. A and b, we don't know what it is, but it still represents the same thing. The base is a divided by b. Exponents 9 minus 2. X is my shared base right here. Exponents 5 minus 4. Can the following expressions be written in simpler form? So you guys pause the video and work these, and I'll get back to it. So 2 to the seventh power divided by 4 to the second. At first you would say no, but they saw that you can rewrite this. 4 to the second power is 16, and so is 2 to the fourth power is 16. So they simplified it to similar bases, and I will show you how they do that so y'all can understand. 4 times 4 is the same thing as 4 to the second power. I can break both of these 4's up into different factors. What is a factor of 2? What is a factor of 4? One of them is 2. And to get 4, it's the same thing as 2 times 2. So all I did was break this 4 into a 2 times 2. And then I'm multiplying it by another 4 of 2 times 2, which gave me 4 2's being multiplied. So it gave me 2 times 2 times 2 times 2, or 2 to the fourth power. That's how they get that. They just break it down into simpler factors. So then I have base of 2, 7 minus 4. Now I have 3 times 5 to the, I can't see them. 3 times 5 times 2 to the 8th power over 3 to the 2nd power times 2 to the 3rd. Remember, this is the same thing. I have multiplication right here, guys. I can just rewrite this as 3 to the 5th power over 3 to the 2nd power times 2 to the 8th power over 2 to the 3rd power. This is the same thing because it's being multiplied. If it was addition, I couldn't do that. But whenever you have nothing but multiplication at the top and bottom of a division problem, you can separate it. So I have the same thing right here. I'm sorry, it's a 3. I have a base of 3 right here to the 5 minus 2. And then I have that multiplied, the base of 2 to the 8 minus 3. And I can simplify that. I just want y'all to see that you know it's subtraction. Over here, they simplified 27 to be 3 to the 3rd power, which is correct. I have 3 to the 23rd power divided by 3 to the 3rd. My base is 3. 23rd minus 3. Over here, I can separate this because it's multiplication. Negative 2 to the 7 over negative 2 to the 5th times 95 to the 5th over 95 to the 4th. That's the same thing as a shared base of negative 2. Make sure that's in parentheses. To the 7 minus 5 times 95 to the 5th minus 4. And our last exercises. Let x be a number. Write each expression in simpler form. I'm going to pause the video and restart this. So remember, whenever I have a fraction and I'm multiplying it by a whole number, I want to make sure that I make them both fractions. So I have 5x to the 3rd times 3x to the 8th power over 1. And then whenever I multiply that, guys, I just multiply across. So 5 times 3 is 15 times x to the 8th power over x to the 3rd power times 1 is just x to the 3rd power. And then boom, I can simply fix that. I have the base is x, but I have 15 being multiplied that, remember? If it was 15 over a number, I would divide it, but 15 is being just divided by a 1 right here. Because remember, x, its coefficient's always 1 if it's not there. So 15 divided by 1 is 15. Then I have a base of x to the 8th power being subtracted by a 3rd power. And that would cancel these out at the bottom. And you're left with 15x to the 8 minus 3. Now I have 5 to the x over 3 multiplied, not x over 3, x to the 3rd power, multiplied by negative 4x to the 6th power. Multiply that out. I have 5 times negative 4 is a negative 20, because a negative times a positive is a negative, times x to the 6th power over x to the 3rd power. Once again, negative 20 stays the same. X to the 6 minus 3 because it's addition and the exponent's bigger. And lastly, 5 to the 5 over x to the 3rd power times 11 x to the 4th power over 1. Then I have multiply across 55 x to the 4th power over x to the 3rd power. I have 55 x to the 4 minus 3. Lastly, and use an online calculator to multiply 2 billion times 2 quadrillion. The answer showed up on the calculator as 4e plus 21, as shown below. Is the answer on the calculator correct? How do you know? So this gets into scientific notation. What all this means is, this is 4 to a certain power of 10. That e means a power of 10 being multiplied by 21 times. So what that means is, you just have 4 being followed by a certain amount of zeros, which is 21 zeros. So the question is that correct? Well, if I have 4 being multiplied by 10 would give me 40, and then followed by, remember, order of operations, 10 to the 21st power means I have a 1 with 21 zeros. So let's see how many zeros I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 zeros. So yes, I would have 10 to those 21 zeros, and then times 4. Would that be the correct answer? Well, I have 2 over here. Let's look at this. 2 times 10 to the 9th power, because I have 9 zeros, times 2 would give me this 2 billion. And then over here I have 2 to the times 10 to the 12th power, because I have 12 zeros. Would that give me 4 times 10 to the 21st? Well, commutative property says I can do 2 times 2 by itself, and then I have times 10 to the 9th times 10 to the 12th. 2 times 2 is 4, times, I have the same base of 10, is 9 plus 12. That would give me 21. So yes, that answer is correct. So sorry about the long lesson, guys. Go ahead and do your problem set and email me if you have any questions. Thank you.